In this series, Histology Abroad, NSH has chats with members from around the world, in countries right next door and those halfway across the globe. We ask them how they got into histology, the challenges and opportunities they see, and how COVID-19 has impacted them. While there are many differences, the commonalities will surprise you. So I'm here with Dr. Guy Orchard, an NSH member from the UK, and he's going to share with us a little bit about histology in England. So let's get started by having you introduce yourself, tell us where you're from, where you work, and how you got into the histology field.
All right. Okay. Well, thank you very much, Natalie. First question was, what is my job title? At the moment, I'm a consultant grade or a consultant biomedical scientist, and the biomedical scientist bit is the equivalent of your histotechnologist bit, but we call biomedical scientists here. And I'm also head of education and training, and I work for a pathology provider called Viapath Analytics. And Viapath Analytics provide pathology provision for many of the South London-based teaching hospitals, which is where I work, in fact, which is at Guy's and St Thomas's NHS Trust. And I have done for about nearly over 30 years now, the same laboratory. And I'm now in charge of that laboratory. And that is St John's Histology Department, which is part of Viapath Tissue Sciences. It's all very complicated, isn't it? Viapath Tissue Sciences. And that is if you equate tissue sciences with histology, and that's what it means. So I'm in charge of the DermPath services plus the Mohs services within the tissue science branch. The hospital I work at is mainly at St Thomas's, although I do also go to Guy's Hospital. St Thomas's Hospital is the one that's directly opposite the Houses of Parliament along the River Thames. It's not Thames. The TH is not pronounced Thames, it's pronounced Thames. So the River Thames, and St Thomas's is on one side, and on directly opposite is the Houses of Parliament and Big Ben. So I actually overlook from my reporting windows Big Ben and the Houses of Parliament. That's quite nice. I have a Mohs service in Guy's Hospital, which is further downstream and closer to London Bridge, and there in the Cancer Centre, a brand new building we've got there, we have our Mohs service, which I oversee as well. So I often flip between the two hospital sites. So the question is, which country? Well, you already know that, England, the UK, that's where I am. And you asked me, how did I get into the field of biomedical science, or histotechnology, as you would call it? This is an interesting one, because when I left school around about 18 with A levels, I'm not sure what the equivalent of that is over in the States, but it's before you have a degree, your high school.
Yeah, high school
qualification, I guess. And you do science disciplines, and I did those. And I was reasonably good at biology. I wasn't very good at much else, to be frank. And I saw in the newspaper an advert to work at St John's in a national newspaper. They were applying for scientists to apply for a position. I applied and I got the job. And then St John's existed as a separate hospital, skin hospital, just behind Leicester Square in central London. So I used to commute up from my village where I lived in middle of Kent. It was an hour and a half, 2-hour coach journey to get me in each day. And I started there, and that's the same lab that I'm now in, that was then merged and amalgamated at St Thomas's in 1990, by which time shortly after that I became in charge of the laboratory. So when I came in, I didn't really know what I wanted to do, but I knew I had a bit of an interest in biology. I quickly learned that I was reasonably good at it, and I worked very hard at it. And so consequently, I passed all the exams. The starting one, we'll talk about the exam process in a bit later. I shouldn't perhaps allude to that now. But there is several years of study to become fully qualified in histotechnology, or biomedical science, as we would call it here. But I'll stop there and ask Natalie what the next question is.
Yeah, well, that actually leads us right into our next question. So I was going to ask you, what is the process or route for someone in the UK to become a histotechnologist, or in your case, biomedical science?
Yes, so I'm sure you have an equivalent thing. There's a registration process to go through. So the first port of call is that now, as we stand, you can't come into the profession to become a biomedical scientist your equivalent histotechnologist, without a degree. Now, when I started 30 years ago, you just had to have A levels, but now it's a degree. So you have to have a degree, and not just any degree. It has to be a science degree, a BSc, and these degree courses also have to contain a certain amount of content that is applicable to hospital science disciplines, okay, which histotechnology is. So how is that monitored? Well, we have a professional body over here called the Institute of Biomedical Sciences, which is the equivalent of your NSH, and they accredit the universities that offer science degrees with an accreditation which says this degree course in this discipline is accepted by the Institute of Biomedical Sciences as appropriate degree for state registration qualification for our laboratory-based sciences. So most universities apply for this and hopefully get the accreditation, which means that students who get that degree can automatically go straight in and after about a 2-year period of training become state registered. Now, if your degree is not accredited, they'll evaluate the degree course and say, well, you're missing components X, Y, and Z, which we require, and you'd have to do top-up modules to complete the requirement and therefore go forward for the registration process. So you finish your degree, hopefully you get into a laboratory employment. Many students do what they call work-based learning, so they are attached to the university to a hospital setting, and they finish their degree and incorporate their degree with working in a laboratory in a hospital in their discipline. And while they're doing it, they're already completing the necessary paperwork for their registration process. So it can be quite quick if you have the right degree course. So on completion of that, you are state registered. Is that the equivalent of HTA over there?
Yeah, so I guess that would be like the HT. But so there's no like qualifying exam to get certified. You're just automatically, as soon as you get out with the degree.
Well, and the registration yes, a portfolio you do, which is sort of managed by the training officer in the establishment that you are working in, or indeed the university lecturers may help you with the portfolio. That's acceptable. That is the basic qualification. Now, after that, when you get the state registration, in order to become a more advanced scientist, you do a Master of Science qualification. So that's the next thing. So you would then do it invariably either attending day release to go to university. There are very few universities that still offer that, or you do it on an online course. Now, I happen to be a lecturer for online courses for masters in cell path anyway, but the process is that you would have a 2-year period of doing assignments online to enable you to pass a Master of Science qualification, MSc, which would also require you to do a project, work-based project, which could take you up to 6 months to a year to complete. So having done the state registration, you then do the Master of Science qualification, so another 2 to 3 years getting the higher degree qualification. At that point, other than aspiring to do management qualifications, which some people do and some people don't, depends what you particularly want to do, you are essentially qualified and you're a specialist, because your MSc would be in a histotechnology, histoscience field. So it might be, for instance, diagnostic immunocytochemistry, for instance. That could be an MSc course. That's the one I'm lecturing on at the moment. Or it could be a broad-based one, or it could be one in molecular science. But either way, you're sort of defining yourself at that point as a specialist BMS, doing a specialist qualification in a specific discipline, histotechnology, for instance. Could be hematology, could be microbiology, depends where you're working and what your discipline is. At the same time as doing an MSc, many of them also do the second portfolio, which is the specialist portfolio, which goes in accompaniment with the MSc and is a specialist qualification to say that you are now a specialist scientist studying histotechnology, or in our case, histology. So that's the process. It's overlapping. It can take several years to become fully qualified. After that, it's really PhDs and things like that are not really mandatory. But what we are doing now, and I'm sure you're doing this in the States as well, is looking at specialist advancements in selective areas of histotechnology. technology. So for instance, the IBMS now has its own exams, which it does with the Royal College of Pathologists, which is your equivalent of the American College of Pathologists, in conjunction with, in our case, the IBMS, and if you were doing it, hopefully it would be the NSH, to devise exams in selective areas. So these would be, for instance, in histodissection. So again, I'm on that board for those exams, and I do mark the papers for students going through those more advanced qualifications. But you can get what they call a higher diploma or diploma of expert practice in selective fields where there is a need for specialist skills. Histodissection is one. We have one for immunocytochemistry, and we are now and have got biomedical scientists who are now qualifying for reporting as well, which has traditionally always been done by the pathologists. So we have got biomedical science doing the advanced qualification for reporting. And it could be reporting in selective areas, for instance, dermatopathology, gynecology, biopsy investigations, it could be lung. And we're developing all these selective modules where you would particularly qualify in certain areas of pathology reporting. So that's the most latest development. So quite a reasonably expanding pathway. As it happens, there's also one in Mohs. I'm chief examiner for that as well. So we have got people studying for advanced roles in Mohs as well.
Right. So I guess that would be kind of similar. We do have like qualifications that the AICP does in IHC and lab safety.
Yep.
So I think that you had mentioned the diplomas of expert practice in the last podcast that we had done, and you said that reporting was based off of a kind of a shortage of pathologists.
Yes.
That's why they had originally developed that program.
Yes. So in a nutshell, what happens over here invariably happens over there. It's been, history tells us that. Normally it happens to you first before it happens to us. But anyway, yes, absolutely. So what's happening now? We've got they've done the statistics, and around about 40-50% of the existing reporting pathologists are over 50-55. So they'll be retiring in the next 10 years, and they can't recruit back to those posts quick enough through the normal RC Path, Royal College of Pathologists recruitment program. So they're going to have an increasing demand and shortage of qualified pathologists. So if you think about it logically, if you have a very experienced biomedical scientist, histotechnologist, in your case, that has a lot of experience, and let's be honest, if you've done the job for 20 or 30 years, you probably look down the microscope quite a few times at quite a few entities, and you're not going to be completely useless at that either. So you're sort of half trained in a way. It sort of makes quite a lot of sense to, rather than starting from scratch, to take those people with the practical experience and the knowledge and get them to do some of this reporting burden that may not be, the most taxing areas, but which would deal with the bulk of the what shall I say, routine type work that the pathologists often get snowed under or bogged down with. And the same thing applies to these dissection exams, because really we want pathologists to look down a microscope and do the reporting. We don't necessarily want them to chop things up. They don't really need to be spending all their time doing that. Or if they do, they only really want to be looking at the complicated ones, not the punch biopsies and the small ellipses. Why do they need to do that? So there's the rationale, if you will, for the advancement and development of these exams, and it's a logical one. And so we're going through this transitional period at the moment. We actually already do have qualified biomedical scientists that are reporting in selective areas, but there are not very many of them at the moment.
So is there a shortage of biomedical sciences as well, or is it just more pathologists that have that shortage?
Well, a good question, and the answer to that is I would suggest there isn't the same problem with the biomedical science recruitment as there is with the pathologist recruitment, because that's rather an acute problem, the pathologists, and I've explained why. And it's also time critical, so they really need to be taking very proactive moves now in order to stop a major crisis in about 10 years' time, or even perhaps less. With regard to the biomedical scientists, because we've got lots of exam pathways, we're developing lots of options, it's less of a problem. I wouldn't say we are blessed with many people, and there is no shortage. I think the truth of the matter is that there possibly could be, but what's happening is, as I'm sure this is the case in the States, rationalization of services is beginning to happen. Mergers and amalgamations of departments is happening, and what happens when you do that is that you increase your automation and you reduce your manpower. So a natural progression here is what I would describe as natural cutback, natural resource management. So you don't need so many hands necessarily to deliver the same volume if you've amalgamated services and improved the efficiency of practice. So it's a complicated equation, but we are managing on the scientific side, although I would say we're only just about managing, and in certain areas of selective specialisms we are probably a bit short, but nowhere near as bad as what's going on with the pathologists.
Right. So you mentioned automation. So I did another interview with someone from the Netherlands who was saying that it was a lot more common in Europe to be completely automated, whereas they felt the United States was lagging behind that a little bit in complete adoption of automation. Do you see that as well?
Right. Well, it depends which discipline you're talking about. So if we're just talking about histotechnology, out of all the disciplines that exist within the hospital sciences, that's hematology, biochemistry, microbiology, I would suggest we are the least automatable discipline of all of those disciplines. That's the first question, because it's very easy to have high throughput volumes and fully automated platforms. If you're doing biochemistry or hematology, it's perhaps not so easy because of the practical hand-on issues that are required in micro, and certainly to a greater extent in histology. Having said that, there is always the ongoing development and progression of automated platforms, and this, of course, improves how we manage our workload. But Natalie, it doesn't take Einstein to realize that all that happens when you increase your automation is you increase your capacity. So on one hand, you're able to do more volumes, and therefore you would suggest less hands at work. But if the work volume increases, and you can't keep up with it despite the automation, you're still going to have to get more hands in. So it's a balance. Unless you have a completely dedicated, purpose-built setup where it is just pathology that's done there, there's no other interactions, you have like a factory approach to how you manage it, then, and only then really, can you make significant cost savings and progress. Now, in the United Kingdom, hospitals exist, certainly in London, because they were there 400 years ago. And I am exactly in a hospital that's been here hundreds of years. It's not purpose-built to run a pathology service. It was built to put beds in and wards 200 years ago, or even longer. And some of the hospitals in London are 400 years old. And they're still there, and they're still open as hospitals. So in those days, they weren't designed to have nice wide corridors and nice ergonomic settings. They're really traditionally very old buildings that have got an immense amount of history. They're much loved, of course, but they're not ideal if you were to try and set up a pathology service that you could easily manage. So there are lots of ergonomical structural layout issues that can be unique to certain countries because of the history of healthcare in those countries. So does that all make sense to you?
Yeah, that's a very interesting point that I hadn't thought of.
Well, if you ever come to London, I can tell you, if you go to most of the teaching hospitals in London, they are hundreds of years old. There's statues of Queen Victoria here, there, and everywhere. There's cornerstones laid by the royals 200 years ago, part of the hospital framework. There's histories of the bomb blast during the Second World War, knocking out whole blocks of the building that were just rebuilt. This is how traditionally in the big cities in England and throughout the UK, hospitals were made, and they weren't knocked down, and they were just added on to for hundreds of years, and that's where we're at. I think I can smell a change now with pathology, though, because they now begin to outsource certain aspects of the services. And so I think a more centralization in a sort of hub and spoke model, where you have a central pathology provider building in a dedicated building to provide healthcare, is the future. And indeed, that is something that we are discussing right now in my establishment. So it's changing, but it's a very, very gradual change.
Sure. So have you seen a lot of increase in digital pathology as well in the UK?
we're a bit slow off the mark on that. Certain parts of the country are doing much, much better than others. I think the big issue here with digital pathology is, firstly, the link ups that you'll require to all the other centres that require the service. So if you're a teaching hospital, you might have to have link ups with 50 or 60 other hospitals that send you referral cases, for instance, so they can discuss cases with you and interchange. So you've got a logistical issue there. You've got a logistical issue about how you store the data from digitalization, because it requires an awful lot of digital storage base, because it's images. You're storing images, and images are big. And if you've got to keep all these images, you've got to have quite a big database to be able to do it. And the third issue is going to be, which system of digital technology are you going to adopt? In other words, you don't want people in one hospital having one system that you're talking to, but you're using a different system, and you've got to have an interlinking other system that works. So what I'm trying to say is, you want to standardize and digitalize systems that you're going to use within your cohort of hospitals that you may be servicing. And that is a key issue of concern, because the process of digital pathology is moving so fast, you can barely keep up with the latest trend before they've changed it and approved it, or changed the software, or changed the storage facility, or whatever they may do. So all of these things are quite involved, but you need to have a very careful consideration of the factors before you make a decision. And then you need to make sure that it's a unified decision, that everybody will have the same basic digital system, and therefore make sure it's standardized, I guess. There's also the medical legal issues, isn't it? Because pathologists generally are used to looking down a microscope. You're now telling them to look at a screen and do it. Now, that may not sound like a massive problem, but if the resolution of the screen is not that good, you're not going to necessarily see the clarity of the image like you would like to see, or somebody would have a different digital system at one end and their resolution is good, but you haven't got the same system, or it's a bit less efficient and it doesn't look quite the same. The colors don't look the same. You tell any histopathologist what the importance of colors are about when he looks down a microscope, he'll tell you, or she will tell you, it's critical. So all of these are very key concerns about how digital pathology progresses. However, undeniably, it's going to happen.
Right. Yeah, and I think in the US, I think that the equipment that they use for it has to be validated by like the FDA or something to maintain those standards before they can use it, because of that specific issue.
Yeah, I mean, it's definitely the future. It definitely makes life easier when you can manage a patient from one hospital the other side of the country who needs specialist care, and you can just make the whole process that much quicker by having a digitalized system where you can talk to somebody on the other East Coast or West Coast in your case and agree management of any given patient. Because we have what we call multidisciplinary team meetings over here, MDMs, and these things are about looking at patients who are not necessarily within our hospital but have been referred to us from another establishment, because we have specialist care for people with those types of tumors, for instance. And there is always a need for this cross-talking to make sure that we fully understand how to manage a patient's condition or pathology. So it's definitely well embedded here, but as far as digitalization is concerned, it's a bit patchy at the moment. We are accepting the progress, but we need to make sure of the standardization, accreditation, validation of all of that procedure.
Absolutely. So is there a body like the CAP here that does inspections on labs to provide a safety standard?
Yes, indeed. So you have CAP. Yes, I've heard of that. Over here, we have what we call UCAS, UKAS. It's actually it's a wide-based laboratory accrediting body, but it doesn't just look after laboratories, it looks after lots of business like companies that do engineering or food manufacturing or whatever. And they have, within the UCAS framework, they have set standards depending on what the discipline is. So in UK, we invariably, most diagnostic laboratories at least, invariably apply for the standards, which is ISO 15189. Long number, but it means the standards for practice in diagnostic laboratory frameworks. So they have a set standards for that, and you get those rules. You'd start working your way through the compliance procedures. You'd apply. They inspect you every year. In fact, you get a major inspection every 2 years, where there's several inspectors coming, and they stay for up to 2 to 3 days, depending on the size of your service. And then you have an interim one every year, which is usually a one-day visit to just to check that you're still keeping on top of everything that they expect you to keep on top of. And then if you pass, you get informed you passed, and that goes on a website for widespread distribution to anybody who might be interested in perhaps using your services. So it's becoming increasingly important that you're accredited to continue really to function as a diagnostic service. And the answer is yes, we do it, and yes, we are approved.
So related to that one, like, is there a lot of private practice there, or is it mostly government controlled since it is a like more public healthcare system?
Yes. Well, of course, the bulk of my work is through the National Health Service. You probably heard of NHS, not the NSH.
Yes.
Oh, God, be careful about that. Quite different, really. But the National Health Service is something that the UK public are extremely protective of. It came about shortly after the Second World War, when, because of all the attrition and suffering and general lower standards, the government at the time decided to reward the public with a national health service. It was a concept which was embraced and is still running to this day, 50 odd years, more than 50 years later. And the concept is that if you're ill, you will go to a hospital and it will be free, and you'll be managed, whatever your condition, and it will be free. And that's still the case. However, the private practice is tangential, running along the same time. And if you have the need for urgent care, or you have to get specialist treatment or second opinions, then that's a private concern. You won't go on a waiting list. You're likely to be seen a bit quicker. And so private practice is available for those who wish to buy it and pay for it. So yes, in answer to you, most of what I do is national health service treatment for the patients that come in, but we do have a thriving private pathology service too. In the area that I deal with, which is dermatopathology, it's incredibly popular for private practice, as I'm sure it is in the US. And the main reason for that is that if you've got a lump on your skin, you can see it, you know when you got it, you know how long you had it, you have a very good clinical perspective of what's going on, and you are likely to go and ask to have it dealt with if you have the money or wish to pursue it privately to get it dealt with quickly. So in skin pathology, generally it's a quite significant private practice option for many people. So and that's what I do. I'm in a skin lab, and so I probably do 50% National Health Service work and possibly nearly 50% private work.
So then I also just wanted to ask, how has COVID-19 impacted biomedical science in your country?
Yes, well, you probably heard all the news over here, because we're having a right. I mean,
We're in a lockdown again, right?
Yeah, we're in lockdown 3. It's a bit like Rocky 3, Rocky 4. It feels like it. I think I've been in the ring several times, but I'm still coming in most days, and I'm traveling into London, and it's a horror story, really. So the reality is, we also have these new strains over here, which I'm sure you're going to get over there. The South African strain at the moment is causing a considerable amount of concern because it has a higher infection rate. It's a mutation of the existing COVID gene, and it's just able to slip through the cells a little bit quicker. Let's put it mildly. It has structural component changes to the virus that enables it to penetrate these cells quicker and therefore infect much more efficiently. So as of this morning, when I picked up the newspapers, they're stating that 1 in 30 people in London has been infected with this virus. So we have a big problem. We are vaccinating rapidly, and I dare say we'll get on top of it, but it's a shaky time at the moment. And in terms of my lab, I very quickly decided and made a decision that we could not all be in the laboratory because we couldn't socially distance. Remember the comment I made earlier that I'm in a Victorian building. I can't poke you in corners. We have structural elements to the building which mean that working in some labs and keeping 2 meters apart is almost impossible with a full range of staff. So I implemented rotations and put people working from home right back in March last year. And we've only had a couple of infections in the department throughout the entire time course, which is almost a year now that we've been doing that. And so I'm maintaining that approach to keep the staff as safe as I can. we do all the sanitization things as well, and we have protective clothing, mask wearing, etc. And we employ that very, very widely. The staff have adjusted extremely well to it. The only problem is that we are uncertain now of our work volumes because the patients, bless them, who've got cancers and all kinds of things, are too scared to come in to central London to have their biopsies done. And this has caused a downturn in workload, which we can't control. It's because of the situation we're in.
We had that too at the beginning. We had a lot of people furloughed.
Yeah, absolutely. And so I'm not furloughing my staff. I'm telling them to do paperwork at home. There's a lot of paperwork that needs doing. We have quality management systems that need paperwork updates. So I rotate my staff. I keep them on full-time working throughout the time course. If I have a vulnerable person, then I would consider furlough or shielding options, but I haven't had to do that. And we have managed the situation very well. The truth of the matter is we are still learning about the full extent of this virus, and we are making decisions based on what is right in front of us. This is a battlefield. It is nothing more than that. And as the armor changes and as the direction of attack changes, so does the defense. So we're in that situation, and I look at it as a battle. And I will change tack and look at strategy of how we're working and how well we're doing, depending on what else is happening in and around my staff and my department. So that's based on experience of doing the job for 30 odd years and having to roll with the punches. So we go back to Rocky 4, 5, I don't know, whatever. That's roughly where we're at.
Absolutely. So I just want to end on a more positive note than that. Are there any new developments in the science right now that you're excited about? What opportunities do you see for biomedical science in the future?
Yeah, that's a good question. And okay, so within tissue sciences or histotechnology, I think the most exciting elements are to do with predictive tests and patient-directed therapies. So how we are now developing strategies to demonstrate specific mutations, proteins that are expressed in a disease pathway, how we then look at those markers, decide what the regimen is in terms of the management of that patient, the drugs they're going to get, the surgery they're going to get, how we implement that, how we then review and maybe change tack. Maybe they're not responding so well to a certain drug regime. We change the drug regime because certain proteins, which we know are significant in the disease course, are elevated, and we change it. So what we're actually doing is prolonging their survival and in giving them better quality of life. And there are plenty of examples in tissue science of this sort of value. So within histotechnology, we've got these BRAF techniques which also applies to histology, where we have an antibody for V600E. We've got the PDL1 story and the lung cancers. We've got HER2 and the breast disease. There's a whole host of these markers which we're now using, and also some of them complementing molecular tests as well. You all know that molecular tests, of course, will govern how we manage disease processes in the future, undoubtedly. However, there's always going to be a need for histotechnology and cellular pathology discipline, because you can't go too far without an H&E for starters. And secondly, sometimes these molecular tests don't work. We all know the importance of fixation issues and variables around processing and tissue typing and all the rest of it. And sometimes a straight section with an antibody on that gives you the result, and I've seen it happen where molecular hasn't managed to produce a result, and we've done it with an immunostain matter of hours and got the result, shows you the complementary value of histology and molecular based sciences in a unified approach to disease management. And that's where we're at. We're at that very exciting stage. I'm just about thinking about hanging up my lab coat. I've got a few more years left, but I'm thinking about it. But having said all that, I hope I'm around long enough to see how this new technology actually impacts and improves patient survival, and also conquers some of the issues we have around cancer. And I do believe that we will eradicate some of these cancers in due time. We will find these targeted mutations, we will bump them off, and people will have a better quality of life. And so ultimately, it's a progressive pathway, but I can see considerable advancement certainly during the time when I first came into the lab and everything was manual and we were just cutting H&Es and doing special stains. And then we started doing immuno, then we started doing in situ hybridization, then we started doing these predictive tests, and it's gone on and on and on. And it got higher and higher in terms of its sensitivity and value. So the future looks bright, I believe. And I think that's the way to look at it.